All right, tree traversals. And so we got a couple definitions to take a look at these. And one of them, the first one is in order. And so the idea of the in order is that it's just that we're going to go up and visit the actual root before we move on to the other vertex. So an in order, sorry, wrong side of my pen. All right, here we go. So an in order would be one where we would start at our left child, and we would move up to the parent, and then we move over to the right child. And so that would be kind of how we'd make that subtree if we're doing an in order. A post order would be where we'd start at our left child, we would address our right child or a left subtree of that. And then from there, then we would go and then talk about the vertex or the root. So it'd be left subtree, right subtree, and then the vertex. Versus in order would be, one more time, would be left subtree, vertex or root, and then your right subtree if there is one. All right. So taking a look at this guy right here, if we wanted to list the vertices of the binary tree in figure 6 in order transversal. So remember, in order would be where we would say, think about this first subtree. So that would be SQT. So there's our SQT. And then once we went from that subtree, we would go up to our vertex. We'd be up here at P. So that's where P comes in. And then at that point, we would go and take a look at the subtree off of there. And so that would take us actually all the way down to V. So we'd have V, U, W. And then whatever last tree is left, there's no left tree necessarily of that. There's just the right tree of R. And so that takes us out to our last piece, or our last subtree off of the vertex. So kind of always kind of working from the bottom, working our way up. When we build these subtrees, we're looking at operations or what, and that kind of helps move through that. All right, so post order, if you go back and just refresh our memory with the post order, we would do the left subtree, right subtree, and then the vertex. So when we build this guy to find the vertices of this one, we would be taking a look at this and saying to ourselves, okay, so we've got left subtree. So first of all, let me back up. We have this subtree of P, and then we have this subtree of P, but then off of that, we have this larger subtree of P. So as we work our way through, we would say S and T and then Q, and so that takes care of that one. All right, and because we don't go all the way up to, we don't go up to the vertex or to the root until the very end. Now we're going to be on the VWU, so VWU. Then from the VWU, we move up and tag R. That's where our R comes in. And then last but not least, we go up to our root at the very top, and that would be the P. All right, a couple more vocabulary things. So we have what's called an infix form and a postfix form. So infix form, the expression obtained by doing an in-order transversal of a tree is called the infix form of the expression. So the expression that we can obtain from that. And a postfix is an expression obtained by doing a post-order transversal. So all we're really doing is just using those in order and post order to be able to get these and to be able to work through these operations. All right, so let's take a look at that. So let's do infix first. So remember, we're doing this in an in-order operation. All right, so let's see. The directions or the question says, all right, in figure 7a, figure 7a represents the expression x minus y divided by x plus y squared as a binary tree. 7b represents x minus y divided by x plus y squared as a binary tree. Find the infix of the expressions by completing in order transversals. All right, so if we're doing in order, Then we're going to work our way. Let me grab my pen. If we're doing in order, I'm going to hit pause just for one second. I'll be right back. All right, sorry about that. So when we take a look at this, our first operation, remember this is going to be x minus y divided by x plus y quantity squared. So this would be x and y minus, that's that first piece right there. Then we would do our x and our y plus, sorry about that, be x plus y. That would be that part right there. And then we would take that x plus y, we would take this expression in yellow, and we would square it. So that's that part right there. And then we take our blue and our purple and we divide it. And so this would make an in-order transversal for 7a would be right there. All right, and then it says, let's make an in-order transversal expression for the next one. So the next one was x minus y divided by x plus y squared. This is in parentheses. All right, so in this particular case, we have to kind of go back and look at how we're going to do this with the order of operations. So the first thing we're going to do is actually do y squared. So this would be y raised to the second power. That's that. Then we would take that and we'd have x. Let me change color. Sorry about that. Then we'd have x plus that. And then we would have y divided by that. So y divided by that stuff. And then last but not least, we would have x minus that. And so that would create an in-order transversal for those expressions. And it's an infixed form. All right, infix form of expressions. All right, so now with the outfix, oops, sorry about that. With the outfix, or postfix, excuse me, then we're going to be looking at this more in the post-order transversal. And so in that case, we are going to look at this in a slightly different procedure. So let's take a look at this. Let's got my pen. All right, so the expression we're looking at is x minus y, x plus y squared. All right, so we want to put this as a post-order transversal, and this is what we're going to yield. All right, so let's take a look at that. I'll be right back. All right, so starting on the left and looking at this subtree, when we do a post order, what we have to remember is that we go x, y, and then our vertex. So when we do that, we've got x, y, then our minus sign. Change the colors. Then we come down here. Then it would be x, y, and plus. All right, building off of that. Then it would be this subtree right here. 2, and then up arrow. So remember, it's this expression. So it's x plus y. So x plus y, quantity squared. So we got x plus y. So x plus y. And then we have that expression raised to the second power. The 2 comes first. And then at this point, we're taking, and since we already have, I'm going to use my color right here. So since I already have, how can I explain this and make it make sense? Let's just add on what we just put on there. So then we would do 2 up arrow, right? Because we've got this, then this up arrow. And now we want to go to the last part. And so in the last part, we would already have this guy. So we'd have the red. And then we would have the all of this guy. That's all of this. And all of that. And then at that point, we're taking that and we are dividing them. So it's our left subtree and our right subtree divided. All right, so that's a postfix of the expression. All right, so now we want to evaluate these written in postfix form. So to do that in postfix form, remember that it would be, so we thought about this as a tree. This would be, this vertex would be a 2. This vertex would be a 3 of that subtree, and then this would be addition. And then we would have, off of there, we would have let's see, how would we draw that? So we'd have a dot coming off of that, and we'd have a 7, and this would be multiplication. And so if we think about that, here we're going to do 2, 3. So our first one's starting off when we have 2, 3 plus. So 2, 3 plus would equal to 5. And then we would have that right there, which is 5. And 5, 7, and then star. So there's our 5, 7. It's right there, 5, 7 star. And star means multiply, so we get 35. On this one's going to be a little bit longer to draw something out, but we'll kind of just break it down and kind of look at it. The tricky part is here is, remember, the operation is always, by definition, it's always the two numbers and then the operation. So when we think about this, we start down here at the bottom. This would be 3, 2, and that would be multiplication. And then at that point, we would have whatever we get there, and then it would be, we change colors, and then it would be 7. I'm probably going the other way. Let's sorry about that. Probably makes more sense. You don't really have to draw these. I'm just doing it to kind of help with the explanation. So there'd be like a 7 here, and then up and down like that, and that would be a minus sign right there. So then that kind of helps us see. So that's why we did the 3, 2 multiplied first to get 6. Because the operation always comes behind the two operands. So this is the operand, and then operation. So on the next one, it's operand, and then, well, actually right here, because that's showing us what we got, the 6. But here it would be operand, and the subtraction. All right, that gives us 7 minus 6, which is 1. And then it would be 1 and 2 squared. So then we'd be taking that guy right there. Oops, wrong color. We'd be taking this guy right here, and we'd have an up arrow, and we'd have a 2 right there. And let's see, so that would give us 1 squared, which is 1. But then we skip over here, and we would have like an 8 and a 4 with the division sign. And then that would give us 2. And then from there, we'd have our 1. So I'd be back here with this. So this is our 1. And then this guy. And that's going to be a plus. So that would be that. So when we went through and worked this, we start off here and we'd be like 3, 2 multiplied is 6. 7 minus 6 is 1. 1 raised to the second power is 1. Then we come down here. So we're sitting here right here with a 1 right here. 8 divided by 4 is 2. 1 divided by 2 is equal to, 1 plus 2, not divided by 2. 1 plus 2 is equal to 3. So that'd be how we work those operands. I think the biggest thing would really to think about this without like going too far about worrying about drawing a binary tree would be is like to think about the fact that like by definition with post order, what that means is that you have an operand, and then an operation. So being able to pull through and realize that you have to have two numbers and an operation, two numbers and operation, two numbers, operation. Right? So two numbers, operation, two numbers, operation, and so forth. So just keep on working our way down that. All right. All right, that finishes up for us for tree transversals. Let me know if you have any questions.